So let's start off with what we call the MPM, or Manufacturing Process Management data flow. As I mentioned to you before, we're going to start with the parts, the data about the products that we're making. Typically they're in the form of a bill of materials called a BOM. We have engineered bill of materials that typically comes from the CAD and the PDM environments, the computer-aided design, product data management environment. Basically, the bill of materials or the structure of the parts and assemblies that are being that are going to be produced, and as the engineers, the mechanical engineers who design them, have conceived them. We're going to start with that because the process plan is really created to create those assemblies or manufacture those parts, and the machines support that, and the layout supports that, the logistics plan supports that. So we're going to look at that bill of materials a little differently, though. We're going to really look at the structure of the product in terms of how we're actually producing it. We may choose to assemble the product different than how it was actually engineered. So while we may still have the same assemblies that would exist and the same parts that would exist as the mechanical engineer designed it, we'll be creating additional parts and additional assemblies, sometimes referred to as phantom parts or phantom assemblies, so that we can define intermediate steps of the manufacturing process and take those steps and assign them to different people or different equipment, or document or move those materials in those intermediate forms. So you can see that the middle of this MPM, starts with an import of the bill of materials. Also, we may get that in the form of a changed bill. In other words, it's not necessarily a new bill of materials, but we made some changes, typically referred to as an engineering change request, an ECR, or an engineering change order, an ECO, which typically means we've modified something. It could mean we've created something, but often it means we've modified something. So we're going to bring these change orders with their associated bills of material into the process planning system, and we're going to define the process around that. And that's going to start with a routing. That's the top level which really of the process plan structure. The routing is responsible for creating the end item, that end assembly, or that end product that we're producing in this process. In that routing, we have operations, and operations are essentially collections of tasks. We'll call those tasks activities for right now. And those activities are actually the work that we perform. Okay? So the elements of work, such as inserting bolts or aligning pieces of material, even an inspection could be an activity. And the collection of activities performed in a workstation typically create what's called an operation. Now, it's possible for operations to exist across workstations themselves, but often these operations are co-located to a particular area in the facility with one or multiple people who are responsible for them. I would say it's more common for an operation to be performed by a person. An activity then becomes the smallest amount of movable work. So I might say inserting the bolt into the threaded hole for a bracket would constitute an activity, because I could do that in different operations. But simply picking up the bolt, that's what we call an element. That wouldn't be something that we could move to another station on its own. We would have to move the whole task of inserting the bolt, but not just picking up the bolt. So elements are one step below an activity. They're really definitions of work that an operator performs, but by themselves, they're not really separatable or movable from the activity. Now, the reason I'm spending time on this issue of the definition of a process is because the activity then becomes a pretty important piece of information. It's really the center of the data management that we're going to do in lean process engineering. We're going to focus on defining activities, as I said, as the smallest amount of assignable work, so that we can create a data management environment that allows us to move activities around and have all the information associated with them and move with them. Things like the work instructions about that activity, things like the time the activity takes, the safety equipment required, the tools required, and the parts that activity consumes. So if I do put a bolt into a bracket, I'm consuming that bolt with this activity, which means that wherever I choose to do the activity, the bolt needs to exist. And if I need a wrench to put that bolt in, to tighten that down for that bracket, then the tool of the wrench also needs to be in the same place the activity is performed. So we've created a little piece of information, a data element and activity, and we've associated really quite a bit of information with that that we're going to carry through the process in a technique we call line balancing, which we'll look at here in just a moment. Now, once this process plan has been authored and it's been validated that it's correct, then we will release that process plan, that routing, with its associated tool information and part information, along with the bill of materials that we're essentially consuming to create the end item, that which we're producing with this routing. We're going to send all that stuff to the ERP system and the MES system so that they can execute that on the shop floor. There are a couple of things that we'll do that are somewhat execution-oriented, such as producing work instructions for the shop floor so that the operators know what to do, or defining the logistics information about the parts that we're moving within the plant, called in-plant logistics. We'll be defining that also as process engineers, and that'll be then the core of what our output represents that the ERP systems consume and run the plant. So it's all of this stuff that I just described that it really makes up process engineering. And there is a very logical workflow here. There's a very logical relationship between data that we'll be talking more about in this presentation. One of the other things that I think is important to mention about these activities is that we also have applicability, such as the models of the products that these activities are used in, or the options. And I want to say that applicability is very important because all too often companies look at each product that they make independently and say, well, here's a task I'm going to perform for this model of this product. When in reality, that task may be performed for 4 or 5 models in many different products. But they don't organize their information in such a way that they can reuse that knowledge, that intelligence, that activities definition, and all of those activities attributes. And this becomes even more important the more we hang on the activity. As I mentioned, if we're doing time studies for the activity, if we're defining tooling requirements for the activity, if we're creating a parts consumed list for the activity, ergonomic studies for the activity, the more we put on the activity, the more important it is that that activity is shared throughout the organization across all the places it's needed. Otherwise, the amount of effort that would go into manage so much redundancy in your engineering effort would simply be unmaintainable. In fact, it's a lot, the reason why this isn't done more often is a lot for exactly that reason, which is that people and organizations tend to put more effort in creating the information than they do trying to manage or reference the information. And then that just makes the information that they create less valuable because it's less leverageable, and therefore they tend to put less on that activity. They don't document the work instructions very well. They don't go into the detail on the tooling requirements because, once again, they don't have time to do that for every single activity in the plant since they're not sharing anything.